welcome to Megarevo and Product Engineer Doris, and this is Megarevo's product training series. Okay, in this video, I will present you how to form 3-power system by using Megarevo's split-phase LNA series hybrid inverter. And behind me, there are 3 12 kilowatt inverter operating in parallel, as they work together to output standard 3-phase voltages. When you use 3 units in parallel configuration to form 3-phase, the system can supply 3-phase loads of up to 36 kW, making it ideal for residential energy storage system, as well as for commercial and industrial application. Parallel 3-phase can support 208 volts and 400 volts. You can choose different working voltage according to your requirement. Before wiring, let's have a brief overview of whole 3-phase system. The diagram showing 3 inverters. AC part including battery side and PV side. AC part consists of grid side and load side. Monster inverter 1 works at phase A. 2 sets battery interface, communication interface, grid interface, and load interface. Also 4 sets PV interface, neutral line interface, PE interface. Slave inverter 2 works at phase B. Slave inverter 3 works at phase C. We use an AC circuit breaker and a grid combiner to make a set of grid cable which is suitable for 3-phase system. Pay attention to the match between the grid cable and the phase port of the machine. Use an AC circuit breaker and a load combiner to make a set of load cable. Also pay attention to the match between load cable and the phase port of the inverter. For PV side, each inverter has 4 PV inputs, and each input can connect to 1 PV string. For battery side, the 3 inverters share the same battery bank. Blue dotted line means communication connection. Doesn't need to connect the communication cable between battery with Monster inverter. This is the cable for parallel communication between Monster 1 and Slave inverter 2. Parallel communication cable between Slave inverter 2 and Slave inverter 3. This is the CT communication cable between Monster inverter and the CT for phase A and B. This is the CT communication cable between Slave inverter 2 and the CT for phase C. All the communication wiring of Monster inverter. All the communication wiring of Slave inverter 2. All the communication wiring of Slave inverter 3. Know the matching between the grid phase and the CT interface. all the system as shown in the diagram. Okay guys, we have already finished all the preparation work in our laboratory, and the next part, I will vary the machine step by step. Let's do it! After wiring all the ports inside the inverter, we need to turn on all the breakers. Push hard, then close the cabinet and lock it. The inverter is ready to start now. The inverter is now starting automatically. Now you can check information from the screen. Click the screen to verify that the firmware of the three inverters are the same. Let's do the three-phase parallel setting for the monthly inverter. Click Setting button on homepage. Enter password 11111. Click Parallel Setting button. Select Parallel Enable and choose Monster. Select three-phase parallel, phase A. Click Parallel Number and enter 3. Click Parallel Address and enter 1. Click Save button to save the settings. Now click the Grid Setting button. Choose 120 to 08 volts. Choose Proper Standard. The default is shown. Click left arrow. Select the grid standard. The default is a merit. Click Save button to save the settings. Now setting is finished. Click Homepage button to back. Setting of Slave Inverter 2 is similar. Now to choose Sleeve for Sleeve 2 machine. Choose phase B for Sleeve 2 machine. Click Parallel Address button and enter 2. Click Save button to save the settings. Similar setting for Sleeve 3 machine. Select sleep. Select phase C. Enter 3 for parallel or drive. All setting is done. Turn on the battery. Press the buttons of the 3 inverters to start the system. Turn on the AC circuit breaker on load side. Let's check the running condition on screen. Make sure there is no alarm and the voltages of the load and grid is normal. Energy flowing. Now the grid is charging the batteries and powering the load. Now let's turn off the circuit breaker of the grid, and the system will switch from on-grid to off-grid automatically. You can see now the battery is powering the load. The electric fan acts as a load. We use an oscilloscope to detect voltage. When we turn off the grid breaker, the fan works normally without any disturbance. Green light refers to grid voltage and yellow waveform shown in load side. It gets red instantaneously. Hello guys, and that's all for this video. We really hope our LNA series can meet your demand, and we will issue more product training in the future. Okay, see you next video. Goodbye.